Captain to bridge.
Spock here.
Any signs of life?
Negative.
Have you tried all hailing frequencies?
Affirmative. No answer from the cube.
Have the department heads meet me on the bridge.
Already standing by.
Life sciences.
Same report.
So are we gonna just let it hold us here? We've got phaser weapons. I vote we blast it.
I'll keep that in mind, Mr. Bailey. When this becomes a democracy.
You realize that the aim will, of course, be very crude.
I don't care if you hit the broadside of a barn. Just hurry, please.
Captain, why should I aim at such a structure?
Mind, Spock. Just get on with the job.
We have been given the scientific knowledge, the technical ability, and the materials to pursue the exploration of the universe. To ignore these great resources would be a corruption of a God-given ability.
It is that man in his quest for knowledge and progress is determined and cannot be deterred. The exploration of space will go ahead. Whether we join in it or not, we mean to be a part of it. We mean to lead it. For the eyes of the world now look into space, to the moon, and to the planets beyond.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
Greetings, my friends, and welcome out to ThisWeekInGeek.net's Future Imperfect. I am one of your mission commanders today. I am Mike the Birdman, but I'm joined by my, resident scientist here at ThisWeekInGeek.net. I'm joined with my good friend from the grand state of Michigan.
I'm Aaron Pollyea.
So last time on the show, we talked about something that was frankly scary as all shit and was depressing as hell, but we tried to end on a more hopeful note when we talked about Logan's One, Threads, and Stalker. So what I proposed to Aaron, and I've been proposing this for about just over a year now, is that we do something on space exploration, because I'm a huge space dork when it comes to anything that's going on above the skies. I know, Aaron, you have a massive background and knowledge of this subject.
Yeah, I'm not an expert by any means, but I did do astrophysics as in my undergrad, and have been like a lifelong space nut. So, I'm not like perfect. I'm not like the 100% for bottom expert that's able to repeat every known fact for it, but I try.
Yeah, so when we started to talk about this subject, I really just wanted to celebrate space, because here on the show we've talked about a variety of different space-based properties. We've talked about Star Trek, obviously, which was how this podcast originally started, but we've never really talked about some super hard science, because frankly the research can be intimidating. It can be a lot to take in, and while we have had really accessible shows like Nova, we had the original run with Carl Sagan, we had the newer one with Neil deGrasse Tyson. There was the Universe documentary, which ran for a number of years on A&E and Discovery. And, if you look on Discovery Plus right now, hopefully before Warner Brothers decides to not kill it, there's a ton of space stuff on there. So the availability of you finding resources on stuff is not hard, especially if you have an interest in science. So, I guess we'll kind of start where our fascination with space really began. And I'm going to go first because, Aaron, I really want to hear yours. So when I was growing up, I went to a very small rural Ontario elementary school. And as I was going to school there, we had a fairly well-stocked library, despite being the size of only a small apartment. And I was immediately drawn to the science section as a child, because I remember going to the dentist office and reading books on dinosaurs that they had there. But I was always more interested in what was going on above me. So during the 1980s, when I was a child, I was born in 1981, I saw the beginnings of the shuttle program. I saw Challenger, Atlantis, Discovery, and all these really, really, really cool things. And I would eventually see the International Space Station. I would see Mir, Hubble, Galileo. And what really caught my attention, I can't remember the name of the book, but I would recognize it if someone put it in front of my face. And it was a kind of a young-ish, it used very simplified language, but it had really good pictures. And I want to say it came out after 1987 because it had incredibly detailed pictures of some of the outer planets. And that means it was after Voyager 1 and 2 had passed by Jupiter, Neptune, Uranus. We saw pictures of Titan, Europa, which are some of the moons. And it grabbed me. And I remember looking, I wish I could remember what moon it was, but it was something so totally alien and wonderful to me that I didn't quite know what to make of it. And then I can't remember precisely how this happened to be, but I remember being in grade 6. And as I'm sure, I hope it's this way in America, but it was like this in Canada. A lot of the schools had access to National Geographic. Mm-hmm. And National Geographic at the time had printed these stellar photographs in full color of Neptune and Uranus and Jupiter, and and I'd never seen anything like that before in my life. And this is when, the probes had completed their primary mission and they were starting to go on extended mission out into the outer solar system and eventually into the Oort cloud at some point. And I was just so taken in by looking at the giant red spot on Jupiter. I wanted to know more. I wanted to know more about the asteroid belt. And that's the thing, though. I've always been fascinated by gas giants or ice giants, as some of them are kind of now called. And I was just always so mesmerized by the colors, their composition, because this is something that no person living will ever touch because it's instant death. But it was just something so wondrous. And I always that's kind of what made me take an interest in STEM, which is science, technology, engineering, and math. And I was pretty good up until about grade 8 when math decided to not be my friend anymore. But I always loved the science and technology with it. And I would always, whenever CNN or whatever cable network would be talking about the space missions, if I could watch it, I would take an opportunity to do that. And I even remember going into the 90s and into the early 2000s when I still lived at home with my grandparents. They had this giant satellite dish in the backyard, the ones that's like the size of like a car. And I remember I found NASA TV by accident one day.
Okay.
Yeah, and I was just going through the transponder channels, and it was just showing a live feed from the International Space Station as it was just going over the planet. Or they'd have these mission briefings where they'd have some NASA scientists come out, and they'd come out and talk for 10 or 15 minutes and then talk to the press. And it was just something that I wish people had really taken an interest in my friend group. I mean, to them, space was just, okay, well, we went to the moon and we have satellites. Cool. Nobody really ever looked 10 minutes in front of their face, and I guess. And it always, I don't know, I guess I was always disappointed I didn't have more people to talk about this kind of stuff with, because one of the first gifts I got growing up, and I really wish I'd taken the time to learn it now, so I'm kicking myself in the ass, I had a telescope. And this telescope was shaped like the space shuttle. And it was really cool because when you opened the cargo bay doors, that's where it kept all your different lenses and all your different kind of viewfinders and stuff. And it even had a kind of tripod. Now, because I'm an idiot, I used it as a toy for my G.I. Joes to go off into space. And I never really took the chance to use it as a telescope. And where I used to live, you would get these giant super moons. You could make out the Sea of Tranquility so clearly from where I was that with a good pair of binoculars, you could make out some really stellar detail. And I used to spend so many nights, usually pining for girls that didn't like me, looking up at the moon and writing poetry because, I'm that guy. And it was just something that really sparked imagination, creativity, and it's something that's been there since, I guess, people really first walked the earth. We've always looked up at the sky. So that's kind of how I started to keep in with a lot of the space program stuff, is just always knowing it was there and always being interested in it. So Aaron, where does your journey start with the fascination with space? Because you're a little bit older than me.
Yeah, I was born in 1977. Actually, I was born about a month before the Voyager probe, Voyager 2 launched. So I always feel like I have a connection with the Voyager probes since they're like, the same age as me. But I don't have a good story for this because mainly I always have been interested in it. Like as far back as I possibly can remember, I've always been looking up into the sky or reading books on space, looking at these pictures and just imagining these different worlds, wanting to just know everything about these strange planets that are even in our solar system, not to mention now ones that we know about elsewhere. But beyond books and obviously doing everything possible space related growing up, even not a whole lot that I didn't really do a whole lot as a kid. I didn't live close to Florida, so I didn't go to see rocket launches. I've never seen the space shuttle launch in person, which is a shame. I met my great uncle Clayton Klein when I was a kid. Let's say I was around 8 or 9. And he had worked on the Mercury, Gemini, and Apollo programs as the head of the White Room. So he was the guy that sealed up the astronauts in their suits and walked with them to seal them up in the capsule. So in a lot of these movies and television shows where you see somebody in thick, dark black glasses, or you see stock footage of those things, that's actually my great uncle. And he was surprised that somebody else in the family actually cared about space. And he ended up giving me all these things that he had collected through the years, which was like, I don't know. It's kind of like getting a piece of the True Cross. Like, as a kid, you're like, wow, this went to the moon. Wow. That's pretty shocking. Right. And it brought more awe into my life about it. Regardless, I never really had a telescope. I actually used my first freelancing gigs paycheck to buy a really sizable personal telescope, and I use it every now and then. It's a pain in the butt to get out and set up because it is so large. I have to wait for a good night, and here in Michigan it's not very conductive to deep space gazing, let's put it that way, just because there's usually clouds and lots of light
pollution.
Yeah, lots of sky clutter and light pollution. So it's not like up in Canada. My wife constantly says, Darlene says, well, if we go out to Vegas sometime, we need to just drive out there and take the telescope so we can just be out in the middle of the desert out by Area 51 with our telescope, and it would be dark enough and we would be able to see everything that we want to see. Because it's a decent size. It's an 11-inch aperture, so I can actually see. It collects a lot of light. It's not the highest magnification telescope that you can possibly get, but it's very good at collecting light. And I that's what I kind of wanted to do, because I wanted to do deep space gazing, with like nebula and galaxies and whatnot. And it's better to actually collect light than actually have a high magnification for that.
What are some of the coolest things that you've been able to see with it so far?
I've seen when Jupiter and Saturn had that very close pass towards each other in the sky. Obviously, they still weren't close together, but we could see both planets in the viewfinder. Well, not the viewfinder, in the eyepiece at the same time, and we could make out the red spot and the rings of Saturn very easily at the same time. And that's pretty cool. It's not something that you generally see. Usually they're separate. Trying to think what else I've seen. I've seen the Ring Nebula fairly well. One thing most people don't get is that the human eye is just not trained to see light very well at low levels. So even like Jupiter, looking at Jupiter, even with the big aperture that I have on my telescope, it looks very grayscale. You can see that the great red spot is red. You can tell that Mars is very red. That's a little easier to see. You can't really tell Saturn's yellow unless the air is very clear. You can though. It's just like I can look up and see the Ring Nebula, and you always look up these pictures of the Ring Nebula, and it's these beautiful colors. And no, that is gray to your eye. It's rare to see lots of color out there.
One of the things that I've kind of taken an interest, because sometimes I spend some time on Reddit, is I see some of the pictures that come out of the astrophotography subreddit. Mm-hmm. And I'm always astounded by what people can capture with their DSLR cameras hooked up to their telescopes. And that's something that you can even do with your iPhone if you have the right attachments to it. If you've got a tripod and something that can track the sky as it moves. Because for those of you out there that have ever tried to do any type of astrophotography without any specialized training, the sky's going to streak just because your finger literally cannot move that fast. Your shutter can move that fast, but are you letting in enough light to actually capture something? And there is there are courses on astrophotography. There's tons of websites. There's tons of tutorials to do it. And you can see some really astounding things. But as Aaron said, your eye doesn't see color and light.
It doesn't see color very well.
Yeah, so there was a photo that I actually tagged on Facebook a couple of days ago. I mean, as of when this podcast comes out, it's been a while, but it's a very well-known picture in the last couple of years where it shows what Pluto actually looks like, but it's color enhanced.
Yeah, so they just basically ramped up the not contrast. What is that term called? Where you really ramp up the saturation, maybe?
Yes, yeah.
And it's there to try to give you the differences in color rather than the actual color. So yeah, it just really ramps it up. It oversaturates things. And that's fine. It gives you the opportunity to really see the differences in color. Like you can do enhanced color photos of the moon. You can do searches for that. And moon looks crazy when it's that way, because to our eyes, even though it's bright and close, to our eyes, it's gray. Like that's what it looks like. That being said, like when the astronauts went to the moon, they said after a while you could get used to it. When you're on the surface, obviously it's much brighter, but you could get used to it and actually see differences in color. That you could see that there were browns and tans and maybe a little bit of yellows here and there, but they were subtle. The moon really is kind of gray.
Yeah, and like one of the cool things that I've kind of learned just by looking at different subreddits and just videos on YouTube is looking at some of the things that we've captured, like looking at some of the moon photography. And we're not even going to entertain the thought that the moon landing was faked. Frankly, fuck off with that.
Yeah, I'm with Buzz. I'll screw off. Don't even waste my time if you're a moon landing denier. I mean, you can go out with the proper equipment and set up a laser and blink it right off the reflectors they left on the moon.
Really?
Yeah, you can.
Oh, that's so cool.
You have to properly target it, right? And when you pop off that laser beam, it's going to take a second and a quarter to get there and a second and a quarter to get back because of light speed lag. People forget that the moon is actually, even though it's close, it's still a second and a quarter away at light speed. So it's a 2.5 second round trip.
That's really cool. I had no idea that was even a thing.
Yeah, you can. Yeah, they left reflectors there, and you can bounce lasers or just even regular light off them and get returns. You have to have proper equipment to detect it, but they're all there.
That's really neat. And that kind of leads me into sort of the meat of our topic here. So one of the things I asked Aaron and put on myself today was to talk about something that really interests you about space. And I chose a planet, and it's our sister planet. You might be thinking, oh, Mars, right? No. I'm talking about Venus. And Venus is the second brightest object in the sky next to the moon. You can always see it at sunrise and sunset. And I learned today, even under the right circumstances, you can even see it during the daytime.
And with the human eye, some people are clear-eyed enough to be able to see its phases.
Oh,
you can actually see if it's a crescent or not with your naked eye. Now, I've actually looked at Venus with my telescope when it was crescent. So that means it was fairly close to sunset when I saw it. Mm-hmm. But it's just like the moon. It has phases.
That's really something incredible. And while I was learning about Venus, I decided to look into the history of exploration. And during the 1960s and into the 70s and 80s, the Americans and the Soviet Union had the space race. And the Soviets beat the U.S. by having the first man-made satellite, Sputnik. I don't need to go into that history. The Americans beat them to the moon. But the Russians did something I didn't really understand. They created the first space probe, really, by all of its definitions. This thing could make course corrections. It could do a lot of things that, that we kind of take for granted today with, your Magellans, your Galileos, etc. And it entered the orbit of Venus. And that was, help me out here, Aaron, I forget the name.
That's the Venera probes.
Venera, that's it. Yeah, the Venera probes. And they had as many as 14 of these things. And first off, that's a goddamn lot of money. But the data that these things brought back was incredible. And the first couple would surround the planet. They would take radar images and gather as much information as they could. But eventually, these things started landing into the atmosphere. And what really tickled me pink about this is some of them actually got down to the surface. You might be thinking, okay, well, big deal. The thing about Venus that people don't get, and a lot of people kind of surface understand, is that Venus is a very hot planet. And that's because of the runaway greenhouse effect, which traps a lot of heat and gas on that planet. So it's very hot. But Venus also has a atmosphere more or less of sulfuric acid. So
yeah, it's carbon dioxide atmosphere with sulfuric acid rain. It's just a terrible place. High pressures at the surface, and obviously high winds. Beyond that, its day is longer than its year, and it actually ends up rotating backwards.
Yeah, which is something that I learned a little bit more today. And as I was going through some of the explorations that I learned with the Venera probes, the Soviets started developing technology that would have allowed them, and did allow them, to photograph the surface of Venus. And we actually got some of our first images back from another planet that wasn't Mars. We got images of Venus. Now, the first couple were only in black and white and at a remarkably low bit rate, even with AI upscaling and different universities around the world trying to enhance them. The picture wasn't great. But as we got into the late 1970s and into the early 1980s, things really took a turn. So they had developed a technology that had allowed the cameras to be mounted in these things that could transmit color photographs, and they were cooled, and they were able to withstand the pressures. And one of these probes was on the surface of Venus, where the pressure is equivalent to being almost 2 miles underwater, and a surface temperature hot enough to melt steel and lead. And this thing managed to stay active for over 2 hours, like 127 minutes or something like that.
Which one? The first one that landed and actually took a picture was Venera 9, and that lasted
57
about 53
minutes.
Yeah, 53 that I know of. 53.
Yeah, so one of the ones in the 1980s was able to return a lot more interesting stuff. And these cameras, when they landed, they explosively blew off their kind of lens caps, and they started transmitting data. And we saw for the first time color photographs from Venus. And Venus is very unique in the regard that it's a very young world, in the regards that a lot of it is volcanic, and we're still not 100% sure, but there are volcanoes on Venus. One of them is, I think, 7 miles high, so bigger than Mount Everest here on Earth.
That Aphrodite crater? I mean, Aphrodite Mons, I think, is the name. I'm not sure offhand.
I think it's Mon Atma. I think it's named after the Egyptian goddess of justice, if I remember right.
Okay, I might be thinking of like the quote-unquote continent.
Yeah, and
like Aphrodite.
And when you look at it, it's because wind speeds on Venus, you can actually hear them. And you might be saying, well, what the hell do you mean by that? So when one of these probes, either Venera 13 or 14, recorded audio of the planet's surface, and this is one of the only times I can think of up until the recent Mars missions that we've really heard what the surface of another planet sounds like. And it sounds like this weird white noise, and you can actually hear a gentle wind on the planet, not like a hurricane force which would exist in the upper atmosphere, but on the planet it's like 20 miles per hour. It's calm. It's weirdly calm. And then in the audio, which you can look up on YouTube right now, you hear the drill. It blows off one of its explosive bolts, and it starts drilling into the Venus soil or rock to start gathering samples, because the second you hit the Venus atmosphere, the clock starts running. So you better get as much scientific information as you possibly can. And it took these panoramic photographs, and you just see what looks like shale stones everywhere. And the sky is this weird pea soup color. And I only saw these for the first time, Aaron, probably in the last year or so.
Oh, okay.
And I was so just in awe. And I can't think of many times in recent memory where I've been in awe of scientific achievement like this.
Yeah, and this was all with like 1960s tech. Think of it that way. Well, let's even say 1950s tech, because a lot of this stuff was designed in the 50s. The Venera Probe 1 that was launched in 1961. Yeah, so a lot of this tech was coming out of the 1950s. So old doesn't necessarily mean bad. And in fact, one might be able to argue that sometimes this older tech would be a little more rugged in really awful conditions. So, I mean, going down and landing on the surface of Venus and surviving for any amount of time is a success. That is a colossal success.
I heard today, and I would love your opinion on this, your learned opinion. Supposedly, now there are several missions planned to Venus, and there's always been a Venus curse, because whenever the European Space Agency, the Russian Space Agency, or NASA wants to do something, it always gets bumped off of the funding thing. So there are missions planned between now and 2032, some of which will be landing. There's the Envision, which is the European Space Agency, and there is the Veritas, which will be done by NASA. And in the video I watched today, they describe they'll be doing mostly radar and high imaging of the kind of to map the topography of Venus. And someone described it as going from a VHS 480i to 4K. But the European space probe, Envision, will be doing it in basically going from 4K to IMAX. It would have a resolution of 15 meters at some point. So the fact that we're going to have these incredibly detailed things, and then a mission that is planned, I think it's called Galileo or something. I can't remember, something with a G. It'll come to me after the program, I'm sure. We're going to be sending another orbiter to the planet, and it's going to take high altitude readings of Venus's atmosphere. But
are you talking about Da Vinci?
That's it. Da Vinci.
Yeah.
So the really cool thing about Da Vinci is at one point they're going to send a rover down to take more detailed surface readings. So imagine with 40 years plus of advanced technology, we could probably see 4K video sent back to Earth.
Yeah, I mean, that would be amazing. The lander is being proposed by Roscosmos, if I remember correctly, because it's a Venera probe that they're thinking about launching in 2029. And hey, if you can land a lander and crawl around on the surface of Venus for an hour, that would be an amazing scientific achievement. Well, engineering and scientific achievement, because the data would be very interesting.
Yeah. And there's so much to learn from Venus, because we know at some point it used to have oceans, and at some point it used to be like Earth, but we don't understand precisely what happened. And that might be invaluable for us to know as climate change happens here on Earth. Can we avoid bad things happening? And there's been interesting things that have been discovered in the atmosphere, which has the scientific community talking about how they have detected a certain type of gas.
Was that phosgene or something?
Phosgene, which may be indicative of a decaying biomass. And there are certain clouds on Venus which don't dissipate. So it's been proposed in theory that could be a layer of microbes living in the high atmosphere, which may be some kind of a exotic life form that is insulated against that acidic atmosphere.
While I would love that to be true, I think that would be incredibly unlikely. I wish it to be true. It's more likely some sort of strange geological activity that is very rare on Earth. But again, we don't know until we go there and check.
Yeah,
right?
like I'm looking forward to seeing what kind of extremophobes are even possible, because like we've even talked about life being possible on the moon of Titan, in those liquid methane lakes. That's a possibility. Underneath the ice of Ganymede, which is one of Jupiter's moons.
Europa, Enceladus of Saturn.
Yeah.
Same things. Yeah.
There's so much interesting stuff in our own cosmic backyard that is utterly mind-blowing when you think about it. And with the current advances in camera technology, metallurgy, nanotech. I know there's a place not too far from where I live here in Guelph that produces nanotubes. And because I live close to the Canadian headquarters for Google, I know a lot of interesting research happens around here. And I know we have somebody, I think there's like a defense contractor around here who builds interesting things that somehow get used in the space program, from what I've heard. But I don't know, because I've heard that through a friend of a friend. So your guess is as good as mine. But it's always interesting just to think about what is out there and what the possibilities are. So that's sort of my little interest in Venus as a place to explore. I just want to know more, and I would love to do more if I guess I had to kind of finish out my thought here before I throw it to you, Aaron, is I would love to see us do more stuff in the asteroid belt, because I know at one point there was talk, and I don't know whether it was just idle billionaires talking about us mining asteroids for material.
Yeah, but we wouldn't want to go out to the main belt to start with.
Yeah, because
what you want to do is, you want to capture a near Earth asteroid, park it into either lunar or Earth orbit, and then mine it there, and use that as a stepping stone, so to speak, to go out to the main belt. Because I mean, not every asteroid's created equal, right? There's carboniferous asteroids, there's just rocky asteroids, and both of those have their uses. But what you're really wanting to do is get a hold of those metallic asteroids, and they're all over the place. But you want to just capture a near Earth one first, and building the foundries in orbit would be difficult, but not impossible. All the technology, we've had it since the 1960s. It's just investing the money in it.
Yeah, it's basically who wants to foot this bill, plus we have to have a reliable spacecraft to get down, and obviously with Elon Musk and Tesla and SpaceX, the possibilities there, just he sucks. So it would be interesting to get more people involved in this space to see what can happen. So
yeah. I mean, it's all the technology's there. It's building it, funding it, and then understanding that a return on investment is not only going to be money, because there would be money coming back from any kind of large scale mining project. It's just that it wouldn't be immediate returns, right? It wouldn't be quarterly returns. It would be more like decadal returns. But the real return on investment would be the technology and research that comes out of all of that. The leaps ahead in rockets or engineering investments. It would just be like, every dollar that gets put into NASA, more than $1 is returned to the American economy. Far more than $1. And it's because of all the research and development that goes on. You want your best investment for your country, invest in NASA. It doesn't matter what nation you are, just give money to NASA, and NASA's going to turn it into something.
Yeah, I mean, I know in Canada, our big contribution to the space program for the longest time was the Canada arm, which was mounted to the space shuttles, and that allowed us to launch so many things into space. And then we've had mission commanders like Commander Chris Hadfield, who is on one hand an amazing person in his own right, but a really welcoming face to the space program for many people around the world.
For sure.
And that's one of those little things you don't really kind of think about, because space gets talked about now and again. You'll get people talking about SpaceX and whatever, but Chris Hadfield gave it a smile. I would refer to him as the Mr. Rogers of space, because I can't think of anybody who has a negative thing to say about Chris at all.
Well, it's because all you Canadians are just so darn nice.
We do try. So Aaron, tell me what fascinates you. What is something about space that you want to tell me about?
Everything fascinates me about space, but I always go back to the thing that actually kind of makes me tear up all the time is the Voyager probes. And not just because of all the amazing things that they discovered around the gas giants, how I feel like that strange connection to them because they're my age. I'm just a little bit older than them, and I've said to my wife, when contact is lost with both of those probes, each time I'm gonna mourn them like a family member gone, because they've been talking back to us every day of my life. Well, since their launch. But I don't really remember that first month. Let's put it that way. But they've been there, right? They've constantly had these discoveries, right? So we built these probes to go out and discover new things. And that is laudable enough, right? We can celebrate all the amazing discoveries that they made, but it's the thing that's attached to them too that shows me humanity not only wants to explore, but it has hope. And it's the golden discs. It's the records that are attached to the Pioneer probes and the Voyager probes. And most people know about them, that they're these little golden discs that were set on the side and they were helped to be designed by Carl Sagan. And it was designed to be discovered if they were discovered by an alien being at some point in the future, that they could be deciphered. And it would give information about where our probes came from, when they were launched, where they were launched from. But they also contained a record that could be played back, that not only had sound, but also pictures that could be decoded from him. And you can go online and see people decoding the actual records to make sure that an alien from scratch could basically, with simple understanding of this is how sound works, or this is how waveforms are, they could decode this. And people have been able to do it within days. So that's not a problem, but it's pictures of just humans doing human things, smiling and eating an ice cream cone, hunting a wildebeest, grocery shopping, dancing. And then there's the music, which is classical music. There's even Chuck Berry's Johnny Be Good on it. And it's all of these greetings that are there. And the one that always ends up choking me up when I hear it is a little kid saying, "Greetings from the children of the planet Earth." And that's hope. See, we talked last week about hope, that a lot of these post-apocalyptic movies have something to deal with, like the death of hope or the destruction of hope or the loss of hope. And it's a rare post-apocalyptic movie that still has hope. But here are these golden records that are attached to these probes, which are specks in the great unknown. We know they'll never be found by anybody after a long time. We can track them for as long as they're sending signals back, and after they're done, they're going to be lost to us. Maybe at some point in the future, we'll have sensors good enough that we can go out and find them again and put a little tag on them or bring them back. But regardless, there's no way that anyone's ever going to find them. But the fact is that we put a record on them with that sheer little sliver of hope that maybe we're not alone.
I think I remember somebody telling me in a YouTube video that I think in, 40,000 years, Voyager 1 or 2 will pass by Alpha Centauri or something, or maybe 400,000?
No one will. They're not going to pass close, quote unquote. I guess in astronomical terms, you could say, yes, they're going to pass close to certain stars, but it's still like light years away. They weren't designed to go towards a specific star.
Yeah,
they were designed to do the grand tour.
Yeah. And that's something that I found very interesting about Voyager 1 and 2, because you think of the solar system as a flat disk, but these guys, when they were launched, they went on 2 different trajectories. Can you explain that to me a little bit better?
Well,
like I'm 5?
Yes, it's that planets move in orbits, right? And they're moving at different rates and at different angles. So they're inclined at different angles. Now, the angles weren't that different between Voyager 1 and 2, but the decision was made that when Voyager 1 passed by Saturn, that they would want to sacrifice the grand tour for it to get better pictures of rings and of the moons. So it would have to move closer to Saturn and therefore get slung out. It would actually not be able to use its thrusters to readjust afterwards to get itself onto a course. So Voyager 2 was able to continue on a wider course that could sling it over towards Uranus and Neptune on the full grand tour. Now that means that Voyager 1 actually, because it got slung out so quickly around Saturn, it got shot out to the north and is north of the solar system. When I say north, it's if you're looking down on the solar system from above the sun, let's say. I know there's no above in space, but if all of the orbits of the planets were laid out below you, that the planets would be orbiting counterclockwise. around the sun. Does that make sense?
Yeah,
When you're
yeah.
you're north of the sun, if that makes sense.
Yeah.
So it got shot out, and Voyager 2 was more along the ecliptic of the solar system.
So, in the years since these probes have been launched, what is some of the most important things that we've learned from either of them? Where do you start?
We've seen Europa up close, and it's ice, and how it's with them. It was, my God, this really is possible that there could be oceans underneath. We've discovered rings around all of these planets that we didn't really think were there. I mean, we discovered them somewhat differently too by these rings, including stars. But it was like, hey, now we have pictures around Neptune of these really gossamer rings. We saw active volcanism on Triton, which is a moon of Neptune. Just going out to Neptune itself is fascinating because it's so energetic for being so far out in the system. Then we get even past that, and them going out into interstellar space by going past the heliopause, where the solar wind slowly has lost enough energy finally that it's the wind between the stars actually has more strength. So it's kind of like this big shock wave out there, where all the particles that are traveling past it are now moving in a different direction. It's now in interstellar space. It doesn't mean it's outside the solar system, because technically that's going to take a lot longer, like tens of thousands of years for it to leave the solar system, because you can define the edge of the solar system being that there's no longer anything that is, there's no influence of the sun, really. Things that are out there aren't orbiting the sun, they're orbiting the galaxy.
Now, one of the things that I think some people don't necessarily understand is when we talk about the solar system, we think of the 9 planets, because Pluto's been reclassified again.
Mm-hmm.
And tell me a little bit about the Oort cloud, what that is, and what's beyond Pluto.
Okay, well, beyond Pluto, there's a couple different things, but the closer in thing is called the Kuiper belt, which is kind of like an asteroid belt, but of icy objects, of comets and things like that. So you get like other bodies that are out there, other minor worlds that are out there that we've discovered, and they're just all orbiting out there. Pluto is technically now considered to be a member of the Kuiper belt. And then there's the Oort cloud. And the Oort cloud is basically just cometary shards that are left over from the creation of the solar system. And it basically will go out to about 2 light years, as far as possible. The only thing that's keeping them around the sun is basically that no other star has come by to sweep them away. And when another star does come to sweep them away, some of them will get sent into the inner solar system, and it's possible that they start impacting everywhere in the inner solar system after a while, and bad things happen. So we don't want that to happen. Regardless, those are the things that are kind of the large structures outside, well, still inside the solar system, but outside of Pluto. But don't think that it's like a science fiction style asteroid belt. Like, it's the Kuiper belt, the asteroid belt, the Kuiper belt, and Oort cloud aren't like that. It's mostly just empty space. There isn't a lot of mass out there. It might be, tens of millions of miles between bodies.
So the odds of Voyager 1 or 2 hitting something, pretty small, I'm guessing.
Pretty low, really low. I mean, they went through the asteroid belt fine. It's mostly empty space too. They were a little afraid of Saturn's rings because that's fairly dense, but they made it through those fine too. Everything's fine.
Now, to swing things on Voyager 1 and 2 one more time, we are over 40 years of mission information, extended information. How much longer are we going to hear from these things? And what have we learned in the last 10 years from these probes that have ancient technology by all modern measure?
Well, we theoretically, okay, so they're powered by radioisotope thermoelectric generators, RTGs. And that means basically there's nuclear material inside these big canisters, and heat is generated by them by the nuclear decay, and they actually use plutonium 238. Yes, 238. And they initially generated about 470 watts of power at 30 volts DC. I know that. Okay. So how long they can go, back when I was a kid, they said they might go until like 2000. Obviously they're still going now, but there's a point of diminishing returns as scientists shut things off that aren't working. And power is continually dropped on these things. So boy, maybe 2030, 2035, when they finally stop having enough power to actually transmit back. That would be my estimate right now. But I mean, I hope I'm proven wrong. I hope they go until past when I die, at least, so I don't have to sit there and mourn them. But it's not like they actually use a lot of power to transmit. Like it's crazy. They're so far away, right? But their transmitter is like 10 watts. So like your light bulb in your refrigerator produces more power.
So that's
stunning, right?
How long does it take that signal get back to Earth?
Oh, it's a long time. See, now I have to look it up because I actually don't know exactly what the round trip, what the light distance is right now for Voyager.
And I think they have to use like that large satellite array in Australia to even pick it up, don't they?
Well, it's the Deep Space Network that they have to use. So right now it's 21 hours 47 minutes one way. So it's closing in on a light day away. So you think light day, wow. I mean, all this time, it's not even a light day. It's 21 hours and 47 minutes. And it's taken all that time to get there. And the closest star is 4.32 light years. We're not even at a light day yet. Space is big.
Yeah. And it's kind of incredible to think of things on that scale, because those Voyager 1 and 2 probes, they're traveling at a pretty good click, aren't they?
Yeah. Around 35 to 38,000 miles an hour.
Like, really, folks, try and comprehend how fast that is. When you really think about it, that's mind-boggling, because there's nothing on Earth that I can think travels that fast as of maybe a particle accelerator. Like, there's no weapon, there's no vehicle that can go that fast. Nothing. And these chunks of metal are going that fast into interstellar space now. And as you mentioned, we'll never see them again, likely. And I've heard, like I mentioned earlier, like how they might pass by relatively close to certain things, but they're going to be a monument to what was on this planet long after our sun goes red giant and eventually goes into a white dwarf at some point in our future. It's still going to be out there, maybe.
Yeah, a little monument to our species and our time. And who knows how many other little probes are like that out there, just floating in interstellar space from species that have come and gone.
Like, there was
we would never know.
There was one space probe, and I think it was one of the Mercury probes, and it was launched in the 1960s, and it's been out there for
Mariner
maybe
probes.
Yeah. And I got thinking about that one night just as I'm falling asleep, and I was just thinking, it's got to be, like, in a weird sense, it's a beautiful journey, but it's an incredibly lonely one. I mean, like, I think a lot about heavy philosophy and what life means, and I often wonder, when my time is up, and because I'm indigenous, what does that mean? And I would often, if I couldn't spend time with my loved ones in the afterlife, how fascinating would it be to be able to explore the great interstellar space of between worlds, to see things that are not meant for human eyes. And I often think about this too before we start to close things out here. I think about how far I want humanity to go. I want our future to be more Star Trek and less Star Wars than I do anything. And I think that maybe I was born at either the right time or the wrong time. You may be saying, well, what do you mean by that? The right time is that I am at the advent of potentially viable space travel, at least on a small scale. And that means something. We might escape this place, hopefully not fuck up the next place that we go to, but thinking about living in a different time, if I was born at a time when space travel is common, even trivial, to think in that mindset, what it must have been like to live now. Like, you think about when the Europeans came over here to North America, and frankly, it didn't work out too well for my people, but that age of discovery is a term that I could use for that, perhaps. And I think about what wonders we're going to see, what it's going to be like for the first human to set foot on another terrestrial world, be it Mars, or be it one of the moons of Jupiter if the radiation doesn't kill them, or when we finally have one of the governments around the world saying, folks, for all intents and purposes, we are not alone. And that may just mean microbial life. It might mean very, very simple life, but that opens up so many doors. And when we think about the money that we're pouring into war, cryptocurrency, or just all the silly little things that happened around Earth to keep ourselves distracted. I mean, sure, I want to see a new Ghostbusters sequel too, but I would much rather invest in the future of our species and deepen that well of knowledge that we've been building up since the first telescopes were invented back in the 1400s. So I don't know, Aaron, if you want to share some philosophical closing thoughts before we close out the hour.
Invest in the future. I mean, not just for like economic reasons. It's investing in our species' future by understanding the universe around us and getting off our cradle. You know, we're still in the soup that we were born into, that we evolved on, that we're just stuck here right now, and we shouldn't be. We have the intellectual capability to leave and ensure that we don't wipe ourselves out through stupidity. So invest in our future, look into space.
Yeah, I mean, ultimately, folks, if you have children, and if I had to give you one piece of parenting advice, and I know this means nothing coming from somebody who's not a parent, but I'll say this: encourage them to take a look at STEM, stimulate their minds, and encourage curiosity, encourage that thirst for knowledge. Don't just look at everything as an opportunity for a paycheck or the next hustle, because I really think someone who's going to be born in our lifetimes is going to do something monumental, fundamentally changing what the face of human understanding is. I really think that, because we stand, as you said, Aaron, we have all the technological resources, we have the right people. It just takes the right person to stand up and do something. So hopefully, folks, we've left you with something to really think about. And I really encourage you, go watch the stuff on Discovery Plus for as long as it's around. Go watch stuff on YouTube. There's tons of these great science channels. There's one's called Simply Space is one that I love. There's some really cool ones. There's another girl, I can't remember her name off the top of my head, but she does these like little 10-minute videos, and you'll learn about, hey, here's the history of Apollo 11. Here's the history of this, that, and the other thing. And just learn. please learn about what is outside of your home. Look up and be amazed at what's out there. So me and Aaron are probably going to be doing one more show before Alex and Steve come back to the show in September. What we're going to be talking about, I don't know yet. We haven't programmed that far yet ahead. But as always, hopefully we'll be doing something exciting as we move into the future, as Twig starts to look towards the end of the year. That's right, folks. We're going to be doing our annual holiday gift guide. We have Halloween coming up. I know me, Aaron, and Alex will be looking at the movies of Mick Garris. We're also going to be doing our salute to John Carpenter as Halloween Ends will be coming out during the month of October. So we'll be talking about some of his lesser known movies that you may not necessarily know from that particular master of horror and master musician as well. We're also going to be talking about some interesting stuff on the prototype. Depending on when this comes out, me and Alex will be doing a discussion about The Last of Us on PlayStation 5. It is his first time through. This would be number 15 to beating the first game, because I'm that guy. And we're also going to be talking about Ninja Turtles, about the Cowabunga collection, and some other really, really, really cool stuff. And we're just going to see what the schedule looks like going through the rest of the year. But trust me, folks, as always, we will have lots of good stuff between me, Aaron, Ken, JT, and Alex. We look forward for all of you joining us. So until next time, for ThisWeekInGeek.net's Future Imperfect, we have been...
I'm Aaron Pollyea.
I have been Mission Commander, Payload Specialist, whatever I am. I've been Mike the Birdman saying, and until next time, folks, live long and prosper.
Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
Computer, this is Captain James Kirk of the USS Enterprise. Destruct sequence 1, code 1, 1A.
Computer, initiate the self-destruct sequence. Authorization Janeway Pi 110.
Computer, this is Captain Benjamin Sisko. Initiate auto-destruct sequence. Authorization Cisco Alpha 1 Alpha.
Begin auto-destruct sequence. Authorization Picard 47 Alpha Tango.
Self-destruct in 15 minutes. There will be no further audio warning.
My lord, the ship appears to be deserted.
How can that be? They're hiding.
Yes, sir. But the bridge seems to be run by computer. It is the only thing speaking.
Speaking? Let me hear.
9, 8, 7, 6, 5.